what's the scariest thing about serverless? There are many scary things, right? Well, some people would say that the scariest thing is long-running tasks, but that's not really the scariest thing because there are many ways to have longer-running functions and things like these. Have you heard about cold start? That was a really scary thing at the beginning, but now it's not that much because with Node.js, your cold start is maybe 100 milliseconds or something like that. What about local development and debugging? That's still a really hard thing to do, but tooling is getting better every day, so it's not really that scary anymore. But there's one thing that everyone is mentioning. It's losing control. Yeah, maybe, but on the other side, with losing control, you're gaining speed and some other things. So I don't think that's the scariest thing. But again, there's one thing that everyone is scared about. And it doesn't matter if you talk to developer or some business person, everyone will mention big, bad vendor lock-in. It's really scary, right? But let's see what's vendor lock-in. If you go to Wikipedia, you'll see that in economics, vendor lock-in makes a customer dependent on a vendor for products or services unable to use another vendor without substantial switching costs. I don't really like definitions, so let's try to explain with a few diagrams. So let's say that you need a server. I don't know why, but you just want to have a server and build some kind of application. You can buy it or rent it, but no one is buying servers anymore. So you decide to rent it. You find a guy that has a lot of servers in his basement. Let's call that guy Jeff. And you rent one server from Jeff, and that's now your cloud. You're using that server, and after some time, Jeff is really smart and he knows how do you use his servers, and he knows that you're building databases, some caching and things like these. So he starts building services for you. You can use just a database without the server, or just use cache or maybe machine learning or functions. And it's even better because you can pay for these things only when you use them. It's really awesome. And you will love your cloud services now. But what if Jeff is actually a villain? And at some point, you're so dependent on his services and he increased costs of all of these services. And of course, your wallet would not be happy in this moment. And you will not be happy for sure. But fortunately, you have some options. For example, you can find another guy that has a lot of servers in his basement or whatever. Let's call this one Bill. And Bill also has a database and compute and machine learning and everything else. And the costs are more or less the same as the cost of Jeff's services before he increased the pricing. But what's expensive is migration, because Jeff's database is not exactly the same as Bill's database. So you need to invest a lot of time to move your application from one services to other. And that's basically cloud vendor lock-in. We saw another example lately with Parler, but that's slightly different because they're not able to migrate to any big vendor. So this is really extreme case, but this presentation will not cover that. Regarding vendor lock-in, I really think that Mark Schwartz, enterprise strategist at AWS, is right. He thinks that term lock-in is misleading because we're actually talking about switching costs. As soon as we commit to any platform or a vendor, we'll have switching costs if we later decide to change that vendor or platform. For example, if you build your application in PHP and then at some point you want to migrate that to Node.js or Go or something else, you'll have a big switching cost because you need to pause for some time, rebuild everything in a different language, and then continue from that point. So how do we fight vendor lock-in? Or let's ask the better question, how do we keep our switching costs reasonable? Well, we can do a few things. First, we need to plan and do planning and analysis. For example, we need to answer some questions such as how likely will I need to switch to another platform or service? What would be the cost for that switch? if there is no big chance to switch to something else, for example, you picked your database and you don't think you will need to switch in the near future, it's okay to have a slightly higher cost of migration, but for some other things, you need to keep that cost lower. You need to have a good architecture, of course. And finally, you need to have deployment procedures, because if you don't have them, it will be really, really hard to migrate anywhere. That leads us to our topic for today, and that's writing testable serverless applications and preventing vendor lock-in using hexagonal architecture. But before we continue, let me introduce myself. I'm Slobodan Stojanović. I'm CTO and partner at Cloud Horizon and Vacation Tracker. Vacation Tracker is a leave tracking management system, and Cloud Horizon is basically an agency. We are doing web apps for other people. I also wrote a book, Serverless Applications with Node.js, with my friend Alexander Simovic, and it's published by Manning Publications. And I'm also AWS Serverless Hero. You can follow me on my website. I write about serverless a lot and testing also. So let's go back to our topic, because that's definitely more interesting than I am. So we'll talk about writing testable serverless apps using hexagonal architecture. But let's focus on testable part first. Why is it testing important for serverless apps? You basically outsource some parts of your app to a vendor, but that's not covering everything. They'll manage infrastructure for you, but you still own your code and your business logic, so you need to test that part of the application. And also, most of the time, serverless applications are not fully isolated monoliths without integrations. Instead, they contain a lot of small services that are interacting with each other all the time, and they have a lot of external dependencies. I mentioned Vacation Tracker, so here's an example. Our application is web app that has also Slack chatbot. And inside Slack, you can type /vacation and request vacation in just a few clicks. It's so easy. You can do that in just a few minutes, actually a few seconds. But in the background, that looks something like this. Slack sends some requests to our Amazon API gateway. API gateway receives that HTTP request and decides which Lambda function to run. That Lambda function will parse that request, send that to something called Amazon Event Bridge that will just communicate with our business logic in the background. It's an enterprise service bus. And then immediately, AWS Lambda function will return the answer through Amazon API Gateway to Slack and tell Slack that we received the message. In the background, our business logic will catch that message and do something with it. For example, request a leave for yours or do something like that. There are a lot of things that can change or fail every moment. For example, Slack can change the payload. It happened a few times in the last few years. Or, for example, Slack can be down. Then Amazon API Gateway can change its payload or something like that. Then AWS Lambda function, maybe our Lambda function is not sending the right message to Amazon Event Bridge, or we don't have rights to send that message, so that can fail. And finally, maybe Amazon Event Bridge cannot trigger our business logic for some reason. So there are a lot of changes that can happen all the time. And tests will not prevent these changes for sure, but they'll make sure that the changes we're doing are not accidental. So how do we prevent changes? We can't. Our application needs to adapt really fast and start working with different payload or whatever. So how do we know which part of the application, what should we test actually in our serverless application? In traditional applications, there's something called testing pyramid. It's defined by Michael Cohn in his book, Succeeding with Agile, and it looks something like this. At the bottom of pyramid, there are unit tests because they're fast and really cheap. You don't need anything external for these tests, so they're cheap and fast because of that. And you need to write a lot of unit tests. Then for integration tests, they're a bit more expensive and slower because they need to connect to some kind of database or other services. So you need less integration tests, but they're also a bit more expensive. And finally, UI or end-to-end tests are the most expensive and the slowest ones because you need to have the whole application and everything. And that's why you don't want to have too many of them. Finally, many teams have some manual session-based testing. That is the slowest one because people need to do that, and they're the most expensive. With serverless, actually serverless testing pyramid would look more like Mayan pyramid instead of Egyptian pyramid. So unit tests are the same, but integration tests and UI tests are a bit faster and a bit cheaper because it's cheaper to spin up another instance of your application, and you pay per things that you only use in serverless, and you can do things in parallel. That's why they're a bit faster. Integration tests in serverless application are cheaper and faster than ever before, but they're also more important because the common serverless application is split into many small pieces. So we mentioned architecture. Which architecture is the best for serverless apps? Basically, there's no one architecture. You can use any architecture that will let you to test your serverless app easily and keep your switching costs low. Because sooner or later, you'll need to switch or migrate parts of your application not to another cloud vendor, but most of the time to you will use another service, or you'll change some integration and things like this. There are some things that you need to consider when you're building serverless application and choosing architecture. You have configuration risk. So if your function is configured as it should, technical workflow risk, if you're handling errors and success responses as you should, business logic risks, if your business logic is working the way it should, and finally, integration risks. For example, if you're connected to the right database and if you have rights to write to that database and things like this. One of the architectures that fits these needs really good is hexagonal architecture, or ports and adapters. Let's talk about that for a second. So its creator, Alistair Coburn, explains it as an architecture that allows an application to equally be driven by users, programs, automated tests, or batch scripts, and to be developed and tested in isolation from its eventual runtime and databases, which is really good for serverless because, as we said at the beginning, debugging and local development sometimes can be a bit more complex than before. It's called ports and adapters because it works the same way as ports and adapters. For example, if you travel in some happier times, if you travel to some other countries, you need a different power plug for your laptop, and you don't want to buy another charging cable. Instead, you can buy a small adapter and just use your regular charging cable. We want to do the same for our applications, and we do that by isolating business logic in the middle, and then we have some certain ports for our events, basically for events, and then we have adapters for different services. For example, when we are testing our service locally, we can use local trigger adapter, and with the serverless app, we can use some kind of Lambda event adapter or something like that. So let's see this in an example. Let's go back to this example, and let's focus on one Lambda function. If we want to build our application in a way that can be easily testable, we can do something like this. We can have Lambda.js file. We do that for vacation tracker that fires the dependencies. That file has no tests, but it has just a few lines of code. Then we have our main JS file, or multiple files that represents our business logic. This business logic has its own unit tests and also its own integration tests. But for example, we have a lot of functions connected to EventBridge. We don't want to test each function against the EventBridge. We have a repository for that, and integration tests will test this against some kind of local repository with the same API and basically the same interface as the real EventBridge repository. And then we have EventBridge repository with its own unit tests and integration tests. And here we want to test that against the real Amazon EventBridge service to be sure that that works. And we can have some helper files, for example, event parser, that will basically run just unit tests because it's not connected to anything outside of our function. So let's see the code for this. This can represent our Lambda.js file. We require some things from, let's say, our business logic and some things for our common folder, whatever that is. And then inside the function, we want to create an instance of our EventBridge repository. And finally, there's a most important part of this code, and that's this line. We invoke our business logic. We pass the event that we received. We pass the parser that will be able to parse this event. That's our adapter for example, Lambda trigger. And finally, we pass the instance of our notification repository. With unit tests, we can easily test this by passing some static values for the event. We can mock parser and we can mock notification repository. For integration tests, we can pass, again, some static values for the event, and then we can pass some parser function and local notification adapter. And of course, as we said, the real notification adapter will have its own integration test, so we don't really care if this function can talk to event bridge. Instead, we just want to check if this function is able to talk to notification adapter. It's simple and nice, but at the beginning, we mentioned big bad vendor lock-in. I'm pretty sure you still remember it. Well, how does this hexagonal architecture help you with fighting vendor lock-in, or, as we said, keeping our switching costs reasonable? Let's do another story. Again, vacation tracker. So we built the serverless prototype in the beginning. We had a small team with one full-time developer. Initial product was serverless chatbot plus Express.js and MongoDB. And it was growing fast. After like a few months, we had more than 200 teams using it. Now we have much more than that. And of course, we had a lot of bad decisions as a bonus that we did in the during that process. So we did a lot of migrations in the past few months and years. For example, we replaced Express API with Serverless API. We replaced MongoDB with DynamoDB, and we replaced API Gateway now with AppSync and GraphQL. Let's focus on MongoDB to DynamoDB. It's really, really hard to switch the database, but with hexagonal architecture, basically you can start with the same interface as we said. So for example, our MongoDB, whenever you want to get the user, you can invoke db.getUser and it will return the user object. What we did with DynamoDB, we created the same interface. So basically, it has the same function, getUser. When you pass the ID of that user, you'll have the same return object. So user1 will be the same as user2. So we did the following. We still have our function and it's connected to MongoDB repository. At some point, we also connected that function to DynamoDB repository and simply switched that adapter in the application. That was just a small part, of course, that is used by our code. But this is, of course, we needed to migrate the data and everything. But it's really important to do this because this way our business logic stays the same. It doesn't really matter for our business logic if the data is inside DynamoDB or MongoDB and how do they work in the background. And if we go back to this integration tests, we can do simply something like this. Before all, we can create a test database with serverless, and after all, we can destroy it. The code is really simple. It looks something like this. We create the table, wait for table to be created. It takes maybe 15 to 20 seconds. And then at the end, we can just destroy that table and wait like 2-3 seconds for that table to be destroyed. And you only pay for this table when you're running tests, and after that, your account is clear. And yeah, you're becoming a superhero of testing. Basically, let's do a short summary to end this presentation. Good architecture helps you to maintain your switching cost low, or at least reasonable. You're not able to really at some in some situations. Hexagonal architecture is nice for serverless apps because it helps you to test these applications in isolation. And you should really test your integrations with serverless apps. Of course, you should test other parts of your application, but integrations are more important than ever. And sometimes tests are not enough, so you'll need to add some monitoring and error tracking to be sure that everything works all the time. And that's it for today. As I said, I'm speaking and writing a lot about serverless. You can go to my website and see the content. I'm also doing testing serverless apps workshop soon. So if you're interested into that, you'll be able to go to my website and get more info. Thank you very much. That's it for today.